Okay, here's your next lesson, which is going to be on graphing functions. So this might be a little bit of a crash course into graphing. You might have forgot how to graph, and I'm going to show you, but you might want to go back. I'm not going to go over graphing in real good detail here, because you are expected to know how to do it. You probably don't remember it. That's okay. That happens, but you might want to go back and review it on your own. Now, one of the things that you might want to do when you're graphing functions is to get the function in slope-intercept form. Now, a lot of the questions that you're going to be dealing with in your textbook are already going to be in slope-intercept form. If you recall, this is the slope-intercept form. Now, you're probably more used to seeing it like this. Y equals mx plus b. Since we're dealing with functions, we don't want to use y, we want to use f of x, which is the same thing. Okay, so here's our first function. Okay, let's graph it. Function of x is equal to negative 3x plus 4. Okay, let's go to the coordinate plane here and figure this out. If you remember anything about the slope-intercept form, the number that is in front of the x is your slope. That's your m. The number that is your constant, that is your y-intercept. This is where it intersects your y. So now that we know what our slope and our y-intercept is, let's go ahead and start. Now I'm going to start here with our y-intercept. Our y-intercept is 4. So I'm going to find 4 on the y-axis, which is right there. Now our slope is negative 3. That's our slope, negative 3. What helps to figure out the slope is to think of it as a ratio, because slope means rise over run. The one thing that you might want to do is just put it over 1 so you give it a little bit of perspective. So this means it's going to go down 3 and then right 1. So you're going to go down or up, always with slope. You go down if it's negative, and you go up if it's positive. And I always tell my students to think of slope like an elevator. You're either going to go down or up on the elevator, but you're going to get right off. You're always going to go right, never go left. So let's go ahead and follow the directions of the slope. Okay, now starting here at our y-intercept, let's move according to the slope, which is down 3. So I'm going to go 1, 2, 3 down, and then the 1 means go right 1, so over 1. And I'm going to do that a few times. 1, 2, 3, and then over 1. 1, 2, 3, and then over 1. I'm going to follow that progression. Now if I want to go the other way, I'm going to do the opposite of what I just did. Up 3, 1, 2, 3, and then left 1. You can tell now that all these points are pretty linear, and there's your graph. That's a linear function right there. Okay, here's another one. I wanted to kind of just practice a few of these so you understand how to do them. In this linear function, we have a lone x. I just got done saying that the slope is next to the x. So if it's just an x term, what is the coefficient next to the x? Well, of course, it's a 1. And if it's a 1, then there's also a 1 underneath it. So it's 1 over 1. Well, no matter what it is, there's always a 1 there. So that's your slope. Your slope is going to be up 1 over 1. So go up 1 and then right 1. Always get right off. Our y-intercept is negative 2. So that's where you start. Start with your intercept. So there's our intercept right there. And I'm going to follow the slope. Now the slope describes it as going up 1, right 1. So that's a pretty easy progression to figure out. So up 1, right 1. Up 1, right 1. Up 1, right 1. And keep following that. So there is your line. So this is a definite linear function. There you go. So to recap what we just did, we start at our y-intercept. That's where you want to start. And then your slope describes what your line's going to look like. It describes whether it's going to be not so steep. It's going to describe whether it's horizontal. It's also, you're going to have a little indication whether it's vertical. You're not going to be dealing with vertical, though. Okay, next one. What we have here is the function of x is equal to 3/4 x minus 5. So where do we start? We start with our intercept. Now notice how when I'm circling the 5, I'm not just circling 5, I'm circling the sign that is in front of it. It's minus sign, which makes that 5 negative. So now I'm going to go down on the y-axis, and I'm going to indicate negative 5. So that's our intercept. Our line will go through that point somewhere, somehow. So it might look like that, it might look like this, it might look like that, like that. I was just kind of making that up, but that's what it's going to look like. So our y-intercept, right there. We know our line will go through negative 5 on the y-axis. Our slope is 3/4. What does that mean? That means go up 3, right 4. Always go right. And why are we going up? Because it's positive. Why are we going right? because I told you to go right. Always go right. Get right off. What we're going to do here is we're going to go ahead and follow the slope. So we're going to go up 3, right 4. So 1, 2, 3, and then right 4. 1, 2, 3, 4. So there's your next point. And I'm just going to do that a couple more times just so I can have some perspective when I draw my line. Up 3, 1, 2, 3, and then right 4. 1, 2, 3, 4. And that's what it looks like. There is your line. Make sure you draw arrows at the end of your lines because this is a line after all, and lines go on forever. This is just a very small part of that line that exists on the coordinate plane. So there we go. What did we just do? We found our intercept. Our intercept was -5. Then what did we do? We looked at the slope. The slope was 3/4. What's the slope do? That tells us what our line is going to look like. So we went up 3, right 4. There you go. So we followed that progression. Up 3, right 4. Rise over run. There you go. That's how that works. This is your last example where you have to graph the function. Okay, I like this example because there's nothing after the -1/3 x. But if you use your imagination, there's something there. What is there next to the x? Well, there's a +0. So if there's nothing there, by default, you can just say, well, it's 0. Okay, so that means that the graph of this function is going to go through the origin, right there. Okay, now the slope is -1/3. Now the negative is right in the middle. But one thing that you might want to do is just indicate that the negative really is on top. Okay, so -1/3. So what we're going to do is, based on that description, we're going to go down 1 and then right 3. That's how it works. So down 1, right 3. Okay, now following that, we're going to go down 1 and then right 3. 1, 2, 3. I'm going to do that a few more times. Down 1 and then right 3. 1, 2, 3. Down 1 and then right 3. 1, 2, 3. If I want to make some other points, I'm going to go up 1 and then left 3. Up 1, 1, 2, 3. 1, 2, 3. And there is your function. Okay, so I just went over how to graph functions. I only went over a few examples. There's a lot more to graphing than what I just did, especially when the function isn't in simplest functional form. It's not always going to be in slope-intercept form. You sometimes have to put it in that form. I think for our purposes today and for the future assignment, you're going to have things that are already in slope-intercept form. Don't always count on that.
If I told you things I did before, told you